Tonight I'd like to talk to you about the future of water. Now, water is the perfect historian. Everywhere it goes, everything it touches, it takes a little bit of that with it along in its journey. And as it passes on, this little record of gases and minerals and chemicals tells the story of every place that it's been. From the clouds in the sky to the mountaintops to the rivers and the riverbeds, through the valleys and the plains below, to the ocean, and from the dinosaurs that roamed before to the fish in the sea, water records that journey for all millennia past. As we have invented thousands of chemicals every single year, things like pesticides and petrochemicals, plastics and pharmaceuticals, cleaning solvents, and cappuccinos. In each of those, water has been used for every industrial process. Things like semiconductor manufacturing and making those solar cells, and from gas fracking and oil drilling. Water, as a perfect historian, records all of that story as well. And the future of water is tied up in the recent history. Now, water is essential for all known life forms. And it's also essential for every form of commerce. So you can't do an eBay data transaction without having a computer chip that used a lot of water to create, or electrical energy to power it that took a lot of water to generate. It's also, even though we live on a planet that has nearly 70% covered with water, very, very little of it is safe enough to drink. And almost all the water we use for any purpose has to be significantly, heavily engineered. We have multiple process steps that it had to go through before it ever got to your cappuccino. Now, in a crisis, we find the real value of water. And first responders use the rule of threes. You can survive for about 3 minutes without air, about 3 days without water, and about 3 weeks without food. And when you think about some of the recent crises we've had in the world, how did we do? When you think about Hurricane Katrina, the United States of America failed to get water to those people, and by day 3, there was rioting over water. In the Haiti earthquake, you had the whole world tried to help the people of Haiti, and thousands have died of cholera and continue to die to this day. And in the tsunami in Japan, you had soccer moms and little children going out and collecting water in buckets and pans from broken pipes and mud puddles, just like this woman and her son in the developing world. It doesn't take long for things to get really bad. Now, I describe the need in the world as water 1, 2, 3. There's about 1 billion people who lack access to an improved water source, 2 billion people who lack enough water for basic sanitation. 3 million people, children, will die this year from waterborne diseases. And right now, half of the world of the hospital beds in the entire world are filled with people with waterborne diseases. The problem isn't just unclean water. It also comes down to the way we transport the water, the way we store the water. The whole system has to be changed and supplied for it to work. Now, the UN has said that safe water is a basic human right. And the World Health Organization has defined what safe water is with these 3 things. First of all, you have to have access to an improved water source of sufficient volume. If you don't have enough water, nothing else matters. But secondly, you have to remove or kill the germs in the water and reduce the toxins in the water to safe levels. And only at the intersection of those is water truly safe. Now, the United Nations millennial goal was by the year 2015 to significantly reduce the number of people who didn't have access to an improved water source. And they've been working on that diligently, and now the nearly billion that are left are in very remote places. And in that process, they've provided improved water sources and access to it. But improved doesn't mean safe. Improved means they might have a well, they might have a pump, a filter, some sort of treatment system. It doesn't necessarily mean that all the germs have been removed or the toxins. And so, who gets safe water? Well, as it turns out, by my analysis, the majority of the world's population does not have access to safe water. They don't have access because most of the United Nations and world governments and corporations and nonprofit organizations are focused on either providing access to water or some sort of partial disinfection of the water. Most of them don't measure toxins or have any way to detect whether they're there, and the solutions they're providing do not remove them. Lest you think you are free of that problem, these are some recent headlines from the United States of America that no one wants you to see. But these recent headlines show that here, even in the United States, we have some significant problems with emerging contaminants that are coming to the fore. Things that didn't exist a while ago, but now are spreading wildly and are getting into our water supplies. Now, many of these, the EPA probably will not regulate or get all the way to having them removed from your water for at least 20 years. It's just a long process for that to occur. Now, you have to decide, are you comfortable drinking trace contaminants in your drinking water for 20 years before the health effects are known? Water is a perfect historian, and its history is troubled. So the goal has to be that we provide safe water to every single person. And we have to also, we're going to need a lot of new ideas in order for that to occur. And the new ideas are things like rainwater collection systems. It's things like gray water treatment systems. It's splitting our water supply into different things and for different purposes. It's reducing the amount of pollution that gets into our water. It's reducing the amount of water we use in different activities. And it's new water sensors and water treatment systems that treat both toxins and germs. All those are going to be needed. I believe we can do it. I believe we're on the way to getting started, and some of those solutions are beginning to be in place. Now, in history, going back a little ways, when I went to school here, the way we took computer programming classes is we punched these little cards, if you can believe it, and we put them in these big boxes. Anybody else do this? Yeah. Big boxes, and then we carried them very delicately over to the computer center. Can you believe that? That wasn't that long ago. Okay? And basically in there you would find computers like this, which were similar to every major corporation. Big central processors with central management that managed things like all the connections and the piping that went to each different person. There was dumb terminals at the end of each one of these, and big corporations ruled the computer world. Look at those names. Where are they today? Most of them did not make the paradigm shift to what happened. And what did happen? Computers became decentralized and simpler to use. And now most of us carry in our pocket computers that are more powerful than the ones I used to carry those boxes of paper, punch cards to. Now in the water treatment world, we have a central processing system that's usually managed by corporations or governments. And it's piped out through dumb pipes and dumb taps all the way to the limits that system can supply. And we have a very similar model to those ancient computers. And this is the model that is being proposed that we should push into the developing world. And this is the model that can't work anywhere to give safe water. Well, it can work some places. It can work if you have enough money, if you have a good water source to begin with, if you have engineers who are trained and can work on this and keep it running, if you have ongoing water funding to keep it going and keep it current with the new contaminants that are coming in, and if you have politicians and environmentalists and corporate leaders all agreeing on this one standard of water that's coming out. As long as all that's in place, it can work. Oh yeah, and everybody in the world has to move to one of those cities. I was at a recent water conference, and I heard these statements. Environmentalists, regulators, and corporations need to drop their agendas and work together to protect our water supply. So all we need is environmentalists, politicians, and corporations to work together and drop their agendas. Governments need to allocate $1 trillion just to replace our aging water infrastructure. $1 trillion just to maintain the status quo. The trace contaminants in our water supply are probably not a significant health concern. Probably not. I feel better. Don't you? It's like someone's performed a Jedi mind trick on everyone, and it's like, don't look here, look somewhere else. This is not a problem. The future of water is similar to the future of the computers. It's decentralized, distributed, where water is got different paths for different applications. Maybe it will have municipal treatment in some places, but it might have in cities. But there might be other things where you're giving different levels and different kind of solutions in neighborhoods or villages, in your family or commercial or industrial, in your household, or maybe even personally. Maybe in your next home, water treatment will be designed into the home, or into your car, or into your bicycle, or into your clothes. Or maybe your cell phone will be used to test whether the water is safe. The future of water can't be like the past. But in order for these new solutions to work, we need to kill germs and reduce the toxins. And it has to be simple enough that this child can use it. It's also going to take new business models that are low cost and sustainable and can work anywhere in the world. One of those ideas, we've got an inventor who's here tonight, Paul Berg, who's invented a way to eliminate boiling in city water. So if you've got water that's being delivered to your place and you need to treat it a little bit more to make it safe, he's come up with a hand crank disinfection system that will work in that environment, that will keep people from cutting down rainforests and having smoke inhalation in order to treat the water to make it safe. Simple, effective. Let me tell you what I've been working on. This is a nanotechnology coated mesh. And this mesh will work by causing as the water flows through this nanotechnology, light activates the surface of the mesh and causes the contaminants, the germs to be killed, and the contaminants to be completely destroyed. We've implemented this in a couple of different products, and look at that picture on the right. Just watch it for a second. The solar bag, which I've got one here, as you fill it with water in the developing world, this nanotechnology-coated mesh will absorb the light of the sun, and the germs are killed, the chemicals are broken apart, the heavy metals are removed from them, and it can be used hundreds of times. This is the kind of thing that's simple enough that it can be used in the developing world, and we've already got some field trials that suggest that it can be adopted in cultures and different places. But technology alone won't solve the problem. You also need to have new business models, new training methods, and new entrepreneurs. Here's a young entrepreneur in Nairobi, Kenya that we've been working with. I love the hand-painted mural on the back and how it shows where the chemicals come from, how it flows down the river, right up to her products that are on the table and how they're used. We're going to need more things like that in each culture. It's also going to require collaboration. You're going to be working with governments and nonprofit organizations and faith-based groups and non-government organizations and local community leaders in order to solve this. This is a program we have called Clean Water, Clean Hands, and it has a couple of phases. In the first phase, you set up a couple hundred families, and you go through training them through schools and agriculture classes, and you monitor it for over a 6-month period, and then you figure out what kind of benchmarks work here. Who's the entrepreneurs then? How will that work? And once we have a sustainable model that works with this water, in this culture, with these people, with this entrepreneur, then you can spread that into a larger area. Water is always local, and you have to solve the purification, the transportation, and the storage of it for it to work. So imagine a world where everyone has access to safe water. Imagine a world where people aren't cutting down the rainforests just to boil their water to make it safe. Imagine that there's no wars that are fought over water or water rights. And considering that most of the illnesses that people have in the world are caused by a waterborne disease, the best pharmaceutical we could ever provide to the world is simply a safe, clean glass of water. Now, the level of thinking that created this problem is probably not going to solve it. It's going to require new ideas, new people to step in, and there's room for a lot of new invention here. But I believe that this generation can create the new future of water, if you can imagine it. Decide with me to become part of the future of water. Thank you.